Okay, hi class. Today we're gonna be talking about chapter 4. It's the chapter about the forces and more about Newton's law. Of course, it's gonna be a brief explanation. I'm not gonna go so much into details so that we are able to cover this chapter. And just to remind you, in chapter 2 and 3, we studied the kinematics, so the motion of objects. And in chapter 4 today we're gonna be talking about the causes of the motion. So in chapter 2 and 3, if you remember, we didn't really talk much about the causes. Why do objects move in certain ways? While in this chapter, we're gonna be talking about the causes of the motion. This is what we call the mechanics. So it is the kinematics and the dynamics, and it will become more clear in the upcoming slides. So to start with this very simple question, what is a force? And a force by definition, and I'm just reading now, a force is a push or pull upon an object resulting from the object's interaction with another object. So best thing to think about forces is to think about examples. Uh, if you are sitting on a chair right now, you should know that your weight, your mass, uh, is making a weight force on the chair, and also the chair is doing an opposite force on your mass. So if you look at this guy, for example, if he's standing, okay, he has a certain mass. Let's say he's like 90 kilograms. So his mass is pulling him downwards, right? There's a force which is pushing him downwards. This is the force of gravity, of course. And at the same time, there's a force on the ground which is pulling him upwards or pushing him upwards. So in this case, we have two forces. We have a force pulling the man downwards, and this is the gravity force. And we have another force which is opposite to the gravity force, which is pulling or pushing this guy upwards. Now, as long as the force upward is equal to the force downward, then you have an equilibrium. If, for example, the force of gravity is larger than the normal force, uh, so what happens is that the guy will fall down, right? He will go in this direction. And vice versa, if the force is pushing him upwards, the normal force is more than the force of gravity, then the guy will be flying, correct? So as long as you have equilibrium, you have no problem. If you look here, you have an apple, for example. An apple would fall from a tree all the way to the ground. The reason is it's the force of gravity, of course. Although you cannot see it, although the force of gravity acts from a distance, it is not something you can see, but we can see what it does to certain objects, to everything with mass actually. Um, Also, if you push and you pull on a door, it's the same concept. And also you have the electromagnetic forces. If you get a magnet, if you get two magnets close to each other, they will either pull or attract each other depending uh, on their sides. And so you also have that kind of a force. So what I'm trying to tell you is that there are different type of forces, and every one of us actually experience many forces during in every minute. In every minute, you experience a lot of forces. We don't feel them, or we are just used to them, but they are all around us. And we have two main type of forces. The first is called the contact forces, and the second type is called action at a distance force. ومثل ما بيقولوا أساميهم يعني it's very direct. Contact forces is when you have two objects that are in contact and they are applying forces to each other. For example, friction force, tensional force. يعني if you have a rope إذا معكم حبل كل واحد عم يشده من ميلة, so each one of you guys are each one of you or both of you are touching that rope and you are pulling in opposite directions. So this is a contact force because there's a contact between the objects. If you think of other type of forces like forces acting from a distance, think of the force that makes the moon orbits around the Earth, مثلا. Why is the moon orbiting around the Earth? Because of the force of gravity. Well, fine, but can you actually see the force of gravity? No, you can't. Because the moon doesn't have to touch the Earth to feel its gravity for this force to happen, right? So this would be a force acting from a distance. Think of electrical forces, the same thing. Think of magnetic forces. إذا بتجيب two magnets وبتقربون على بعض, they don't have to touch each other. ما ضروري يتقربوا ببعض لتبلشوا تحسوا بforces. In fact, you're gonna feel the forces before they even touch each other. So في forces that need to be in contact, مثل التنشن, مثل الفريكشن. Tension, mainly think of ropes. Friction هو if you're moving in a car and you hit the brake, the force between the tire, between الدولاب والأرض, is that force of friction. We're gonna talk about it anyway. And forces acting from a distance, like have we said, are forces that do not need to be in contact, مثل gravity, electricity, and magnets. إذا بتذكروا from the previous chapters حكينا عن ال vectors. This is the force. This is how you represent the force. حتى تعرفوا and this is very important that the force is it's a vector, so it has a magnitude and it has also a direction. So let's always remember that. في كمان شيء اسمه the net force, which is the sum of all forces together. Best thing here to do is to look at this example. Assume you have this ball في 3 أشخاص. This is a rope, حبل هون وحبل هون وحبل هون. كل واحد عم يدفش على ميلته, right? If you want to find how this ball will it move in this direction, that direction, this direction, or maybe in this direction? I don't know. So if you want to know how it will move eventually, what you do is you add these forces. You say the net force, the summation of all of these forces is equal to F1 plus F2 plus F3. Once you do this, you can actually calculate the net force, the total, the vector sum of these three forces. And in the coming examples, I'm gonna show you كمان بالhomework, you're gonna be doing some of these net forces. Again, this is very related to the vectors that we have covered in the previous chapters. Okay, this is why we had to go over some basics about vectors in order to be able to continue with this chapter. So yeah, so f net, f total is equal to f1 plus f2 plus f3, right? And then you add these vectors so that you can tell what is this f net in the end. And another example here, I've already mentioned this, is عندكم طاولة وفي كتاب. This is very similar to the example I gave you. إذا واحد قاعد على الكرسي. So look at this book here, okay? A very simple question. What are the forces acting on this book? Well, there are two forces. One force is pulling this book downwards, and this is the force of gravity. مثل العادة gravity دائما بينزل نزول. But at the same time, the table itself is applying forces on the book to push it upwards. As long as the book isn't moving, يعني the summation of the forces is equal to 0. So أول شيء أنا بكون أعطيكم هيك رسمة, okay, and then I will ask you to sketch the forces acting on the book. تيجوا بتطلعوا هيك تقولوا اوكي شو الفورسز هون؟ well في gravity دايما نزول وكمان الطاولة عم تعمل فورس طلوع. So it will be something like this. Now W نازل يلي هي gravity, normal force طالع طلوع opposite to the weight. So if I ask you find the F net, okay, you have to add all of the forces. So F net is equal W plus N ببساطة. بس بهالحالة what is F net? You see, you have to ask a question. Is the book moving? It's not moving in this case. So if it's not moving, then F net يلي هي equal لهيدا الشيء W plus N يلي هي كمان equal to the mass times the acceleration, if you remember. And in this case, the acceleration is 0 because the book is not moving. So F net is equal to W plus N, which is equal to 0, right? This is the case again لأنه the book is not moving, and even if the book is moving with the constant velocity يعني its acceleration is 0, يعني it will also be the same. So بهاي الحالة بيطلع معي W is equal to minus n vector إذا بدكم تجيبوا هيدا للميل التاني. Okay, let's talk a bit more about these forces. This is the example that we have. This is very similar to what I have just mentioned. But look, بهيدي الحالة, بهيدي الحالة you have a book, but in this case the book is moving to the right. Okay, عم يمشي هيك. طيب, if the book is moving in this direction, naturally the table or the ground which the book lies on will be applying an opposite force to the direction of motion of the book. يعني إذا في شيء، إذا هذا الكتاب عم يمشي هيك بهالدايركشن، أكيد تكونوا أكيدين إنه the friction force يلي هو هذا الفورس هو بسبب الاحتكاك بين الكتاب والأرض، بين الكتاب والطاولة، بين الكتاب وات ايفر هو على شو. لأنه هذا الكتاب بده يمشي بهالدايركشن، بده يصير في احتكاك بين الكتاب والأرضية تبعه. So there will be a friction force, and that friction force will try to push or pull the book in the opposite direction. تكون example، إذا هلا أنتو في نزلت، إذا هلا بدكم تزيحوا طاولة، أوكي، شو بتعملوا؟ تحطوا إيد هيكون على الطاولة and then you try to push it in your direction. كيف بدكم إياها؟ whatever you want to pull it to. But what's gonna happen, you're gonna find that it is really hard to do this, right? And you're gonna find that the table somehow is doing opposite forces on you. So you have to push harder in, right? So this partly is caused by the mass of the table, and partly it is caused by the friction between the table and the ground. يعني حتى السيارة، الدولاب السيارة لما يمشي على الزفت، طيب ما بيصير في احتكاك بيناتهم؟ Of course. So you have friction between them, and again the friction always try to put forces in the opposite direction of the motion. يعني إذا أنتوا ماشيين بالسيارة على اليمين، الفريكشن بده يحاول يدفشكن على الشمال. إذا ماشيين على الشمال، الفريكشن بده يحاول يمشيكن على اليمين, and so on. It is always the opposite direction. Okay? هون على فكرة كمان if you wanna do the F net انسوا ال x-axis, انسوا the friction force. The F net is equal to the weight plus normal is equal to the F net, which is equal to m times a. Acceleration is 0 لأنه ما عم تطلع وتنزل velocity أو speed, so W equal minus n. بهاي الإكزامبل اللي تحت أمرار حتشوفوا بالهومورك أو بالإكسرسايزز إنه حيلكن إنه the book or whatever object you are studying is moving on an airtable here. Whenever you see this word, this term airtable, يعني عم يقلكن إنه ما في friction. عم يقلكن إنه forget about the friction and assume you have no friction force. Just wanted to clarify this. So let's talk about actually whatever we have mentioned so far is basically what we need for part of this chapter. So نحكي شوي عن Newton's laws يلي we have already covered anyway. So Newton's first law says if the net force of an object is zero, then the object maintains constant velocity. لأنه إذا ال F net is equal to zero, يعني ال mass times the acceleration is zero, يعني the acceleration is zero, يعني the velocity of the object will always be constant. مظبوط؟ فكروا فيها. Uh, and the velocity the velocity can be constant and it can even be zero, right? The velocity تكون zero and Newton's first law will still be applied. So هيدا first Newton's law. In Newton's second law, an object acceleration and the net force acting on it are proportional to each other. هيدا الشيء نحن we have seen it before, we have worked with this formula before in the previous chapters, and now I'm telling you this formula is the Newton's second law. It says F is equal to the mass times the acceleration. Acceleration is zero if velocity is zero or if velocity is constant. Okay. الفورس اليونت تبعها نيوتن، الماس اليونت تبعها كيلوغرام، الاكسلريشن اليونت تبعها is meter per second square. كمان شيء شايفينه من قبل. let's look at this example. Alright. This is if you have a spring هون راسور وعندكم هون a block mass, and what you are trying to do is you are trying to pull the string in the right direction. وهيدي الماشين هيدي it reads to you, it tells you how much force in Newton you are applying. يعني انتوا عندكم mass spring راسور وعم تسحبوا هيدا الراسور اللي عندكم. هيدي الماشين هون بتقلكن قد ايه الفورس يلي ايدكن is applying on that spring. Okay, so نرجع على نيوتن second law. F equal mass times the acceleration. دايما بالplots what we do is remember y equal slope times the x. This is the equation for a straight line. So on the y-axis we plot the F force, the F net. On the x-axis we plot the acceleration. slope هوني بيطلع معي nothing but the mass. One example of a force is the weight force, which is the mass times the gravity. So if you would to also plot this on an y direction, فيكن تعملوا ال y-axis بيكون ال w and the x-axis بتكون the g in this case. So don't worry about this really, okay? And finally, Newton's third law, it is, you know, this law is the law of opposite forces. يعني if you apply إذا أنتو you put your hand on a wall and you try to push that wall, you will be applying a force from your hand onto the wall. Let's call it FA on B. A is your hand, B is the wall. عم تدفشوا الحيط. Now إذا أنتوا دفشتوا الحيط بقوة كتير بده يوقع الحيط, right? So you would win. But if the wall doesn't move, يعني the wall is pushing back on you. And the wall is pushing back on you with the same magnitude but opposite direction. So it will be pushing back on you with force FBA. Force that the wall is applying on your hand. This is the Newton's third law. بيقولكن إنه كل action فيها reaction. كل force you apply to something, that thing will apply an opposite force on you. And this is really how it goes. And the same thing goes with the planets and with the moon, with the sun. The moon بيعمل force على الأرث بس كمان الأرث بتعمل force على المون and so on. Same magnitude بس opposite direction. هون example بفرجيكم إذا في شخصين عم يدفشوا بعض. A big man وزنه 80 kilogram and a small kid وزنه 50 kilograms. Both are, pushing on each other, okay, uh, in some forces. And eventually, when they release each other, كل واحد حيروح direction مختلفة.